Okay, so this is a question, differential equation question. Colony of microorganisms in a dish is growing at a rate proportional to the number of organisms present at any time. So there are initially 1,000 organisms. Write down a DE that models the growth. Okay, so in this case, uh, for DE forming of equations, recall that it is always the rate of growth, okay, the rate of growth or rate of increase minus the rate of decrease. Okay, so for such a question, increase means the growing part, and decrease means if the organisms dies or anything. Okay, but for this question, there's no rate of decrease, so basically it's just the rate of increase. So we can start the question or start the answer by saying that let x be the number of organisms at any time, of organisms at any time. Now, why you need this? Because at any time. We need this because there is no like reference or anything, so we need to show this in our presentation. Okay, and t be the time that's okay. T be the amount of time passed. Be the amount of time passed. So now we define our x and t. Okay, therefore the x dt, is proportional to x, which means that the x dt equals to kx, where k greater than 0. K is a positive constant. Okay, why? Because it's about a positive growth. If k is negative, it will be actually decreasing. So that's not what we want. Okay, so next part, very simple. We will be solving the dE. So 1 over x dx equals to k dt, and then you integrate by variable separable. Okay, so from here, pretty straightforward. Ln of mod x equals to kt, remember your plus c, x modulus equals to e power kt plus c, and x equals to plus minus a, no, plus minus, okay, let me just remove that, e to the power of c, e to the power of kt, okay, equals to a e kt, where a equals plus minus e to the power of c. Okay, recall this is the way we remove the plus minus. Okay, so we throw it here. So when they tell you that, you can realize that when they tell you that there are initially 1,000 organisms. Okay, so we can let when t equals to 0, x equals to 1,000. So therefore 1,000 is equals to a e to the power of 0. We have a equals to 1,000. Okay, so from here we get that x equals to 1,000 e to the power of kt. Now they did not give any other thing already, so okay, I'm actually in the second part already. So for the first one, right now the differential equation, the answer will just be here only. Okay, so the first part is this one, dx dt equals to kx, finish, and then you must remember to write this. Okay, so I actually went on to the second part. Okay, so now, okay, so the first part is just dx dt equals to kx, and then now we go on to the second part here. They give you that it doubles in size in t hours, and find the time taken to triple in size. So now that we have this here, okay, we need, when x equals to 2,000, double in size, t equals to big T. So we have that 2,000 equals to 1,000 e to the power of k big T, or e to the power of k big T equals to 2. We want to find when triples, what is t? When x equals to 3,000, 3,000 equals to 2,000, not 2,000, 1,000 e to the power of kt. We want to solve for t. Okay? So what happens is that there's actually an e power k that we can play around with. Okay, so from e power kt equals to 2, we have kt equals to ln 2 and t equals to 1 over k ln 2. So we'll be we'll be using this. Okay, or to be more proper, sure, we should be making k the subject. K equals to 1 over big T ln 2. Okay, because T is the constant here. So now we have 3 equals to e to the power of kt, or kt equals to ln 3. Okay, now remember k, we have our k as 1 over t ln 2, just need to sub it in. 1 over t ln 2 equal times t equals to ln 3. Oops. So t equals to, bring over ln 3 divided by ln 2 times t, and this is the answer. Last part, give a condition which the model may be inappropriate. So this model is such that at every time t okay, every time t big T it will double. So when will it not double? Okay, is when there are many potential answers for this. You can probably say that the dish is full, a dish is full or near full. Okay, so when it's full, right, it cannot grow any more organisms. Okay, so that is probably one condition. You can also have conditions like there may not be enough nutrients. So all these are not really maths related, but more logic related. Really. But it will, in terms of maths, it will be like it will affect the rate of growth. Okay, so that will be something like one of there are many potential answers, huh? So that's for this question.